All right, in this video, we'll look at one more example of trigonometric substitution, and this one is probably the most challenging because of that weird 3/2 power, but let's see if we can deal with that. Okay, so the first thing you need to remember is which substitution do we use? Well, if you have something like a squared minus x squared under the square root, then x is a sine theta. If you have a plus in between, then that would be a tangent theta. And finally, if you have a minus, but it starts with an x, that's secant. Okay, so secant theta. Now, what do we have here? Well, you have to understand what this stuff is on the bottom. What that is whenever you have power 3/2, this is the same thing as square root, but then you are raising that to the power 3. Okay, so we generally in this case have case number 1, right? So this is 1, 2, 3, because the number starts first and then we have a minus. Our substitution is going to be 4 sine theta. Trigonometric substitution is weird because usually you have u equals something of x, but here you have x equals something of theta. So think about it this way. You started with English, which is x. You translated it to theta, which is, let's say, Russian, okay? So you said hi, but then the Russian-speaking person doesn't understand that, so you have to translate it. You have to translate it to theta, and you have to say привет. Okay, and that's what you need to do. Translate from x to theta. Translate from English to Russian. Okay, what is dx? Well, that's 4 cosine theta. All right, so everybody remembers that sine becomes cosine. What about the root? Okay, so let's deal with that. Why is this substitution going to work? Because when you square your x is 4 sine theta. 4 is squared, that's 16, and sine is squared, that's sine squared. And now you can see that 16, right? Both terms share, so you can pull it out. From the first term, there's nothing left, so you just put 1, because 16 times 1, right? Times 1 doesn't change anything. And then minus sine squared theta. Why does it work? Because we have trigonometric identity number 1. Sine squared plus cosine squared equals 1. And from here, if you solve this for cosine squared, you got cosine squared equals 1 minus sine squared, which is exactly what we see right here, right? So now we see that this is 16 cosine squared, and that is a perfect square, which is exactly what we want. And this is 4 cosine theta. Now, let's say you started with the wrong substitution. You started with tangent. Why would this not work? Because 1 plus tangent squared is secant squared. But what about 1 minus? There is no identity like that. It wouldn't have worked. Also wouldn't have worked with secant because 1 minus secant squared is nothing. There is secant squared minus 1, but not the other way. But this one specifically works, and you've got right here, oops, stop. We've got 4 cosine theta. All right, let's transform our integral, translate everything from English to Russian, from x to theta. Okay, think of this on the bottom. Let me actually rewrite that right away. This is going to be square root, and the square root is cubed. Okay, and then dx. Okay, first x is squared, so 16 sine squared theta. Do not forget to square everything, 4 and sine. With the square root, we just transformed that to 4 cosine, but we are cubing that. So 4 is cubed, that's 64, and cosine is cubed. And then dx, remember, don't just drop it, dx is 4 cosine. Okay, so let's see if we can simplify that. Well, the good news is the numbers are going to cancel. So 16, 4, and 64 cancel out. And also one of the cosines here is going to cancel out, and this is going to become cosine squared. So I see this as sine squared divided by cosine squared, right? But what is sine over cosine? Well, that's tangent. And so I wind up with the integral of tangent squared. Now I translated it, right? Okay, so now I can, integrate it. Okay, so you're gonna now actually integrate tangent squared. And how do we do that? Well, again, we need trigonometric identities. They're everywhere here. Tangent squared plus 1 equals secant squared, right? So instead of tangent squared, I'm going to put secant squared minus 1. Now, how do we integrate that? Well, secant squared is one of the integrals that everybody needed to memorize. That is tangent. And 1 becomes just theta, right? Because generally integrating a number is like, let's say 5 is 5x. 1 is 1x. But here it's not x, it's theta. That's why I'm saying minus theta. Okay, so we've got this answer right here. But now we have to translate it back, right? From Russian back to English. Okay, so here, let's put that what we got, that tangent squared theta. Out of all that's here, it was so simple, it's now just tangent squared. Now we have to label our triangle. How do we do that? Okay, so let me draw the reference triangle. This is going to be, well, this doesn't look particularly great. Okay, so we got an angle theta here. So this side is opposite. This is adjacent. This is the hypotenuse. So adjacent is right next to theta. Opposite is opposite from theta. And hypotenuse is the longest side. Okay, and we got our SOHCAHTOA, which I'm sure I'm not pronouncing right. Okay, here's what we're going to do. We're going to go back to our substitution, which was 4 sine theta. So x equals 4 sine theta. We're going to divide both sides by 4. So this is x over 4 equals sine theta. From our mnemonic rule, right, we know that sine is opposite over hypotenuse. So this is opposite over hypotenuse. So we now know that opposite side is x. So this is going to be x. Our adjacent side, we don't know yet, but hypotenuse is 4. Okay, so for the other side, it always has to match the root in the problem, the square root, which was square root of 16 minus x squared. So this should be 16 minus x squared, which hopefully everybody understands is not 4 minus x. Now, why does this work? You can always check your work by using the Pythagorean theorem. Pythagorean theorem says that if you take adjacent side, square that, which just means 16 minus x squared, you add the opposite side, that should equal to square of the hypotenuse. And is that true? Well, yes, because negative x squared and x squared cancel, and we got 16 equals 4 squared, which is 16, and that's true. So we just checked that what we did is correct. Okay, the only other thing we got to do is, again, translate this from Russian back to English. What is tangent? Tangent is opposite over adjacent. So let's take x divided by the square root. Okay, that's great, but what about that theta? What do we do with that? Okay, so this is a good question. Theta, you have to also express somehow in terms of x. So usually what you do is you go back to x, what it was, and try to solve this for theta. And usually we only like to use arcsine and arctangent if possible. In this case, I'm going to use arcsine. So I will divide both sides by 4. And I get x divided by 4 equals sine theta. The triangle is not useful here, okay? Because we need to get theta from here. How do I get it? I gotta get rid of that sine, okay? But I hope you understand you can't just divide by sine. That doesn't work. You have to apply inverse sine. So inverse sine, when applied to sine, they kind of cancel out or they undo each other's action. So this is going to become arc sine of x divided by 4. That's a very tricky part.